Flip to the last page of your notes, please. One more time, we're going to come back to this idea of the converse, because oftentimes the converse of one of our conjectures is also something we should investigate to see if this is also going to always be true. So the converse of the isosceles triangle conjecture, once again, remember, a converse switches the if and then parts of the isosceles triangle conjecture, or any conjecture, it switches the if and then parts. So recall, the original conjecture said if the triangle is isosceles, then the base angles are congruent. But we're now going to start with if the base angles are congruent, then the triangle is isosceles. So that would be the converse. We're going to start with the base angles being congruent and then see if the triangle is isosceles. So that's what we're investigating in number 6 here. We're going ahead and we are constructing a triangle with base angles congruent. So if you want to do a quick construction here with your compass, that would be optimal. Otherwise, we're going to sketch this in. But we're just going to make a segment on the bottom of our triangle, or whatever size you want. So from A to B here, we just made a segment. And then from each side, we're going to make an angle. So just use your straight edge and make an angle from one side. And then copy that same angle onto the other side. So you're going to make one angle just with your straight edge, whatever angle you want. But then you're going to come over and use your congruent angle construction here. So making an arc that goes through the original angle and then down here, measuring out the distance between these two parts, and then making your second arc over here. And extending that line up until the two sides meet, which would be right here, and we'll call that point C. So the question is, if the base angles, if we have two angles in a triangle that are congruent, does that automatically make this triangle isosceles? Well, if you now take out your ruler and measure the two sides of your triangle, right here and right here, the two legs, we will find that indeed these two sides are congruent to each other. So if we start off with the fact that angle A and angle B are congruent, then we do find out that the side AC and BC are always going to be congruent. All right. So we showed that in a couple different ways. Down here in the key I kind of talked about, you could also use patty paper to show this as well. I think the construction with our compass works out pretty well. And so we're then going to state our third property for today then, which is called the converse of the isosceles triangle conjecture. So it says, if a triangle has two congruent angles, then it is isosceles. If the base angles of a triangle are congruent, then the triangle is isosceles, would be another way of stating that. So hopefully just kind of sketch out this little diagram over here as well. So we're saying if this is true, if we have two angles congruent, then we automatically know that the two legs of the triangle are also congruent. Right, so today we talked about triangle sum conjecture, talked about the third angle conjecture, and we talked about this isosceles triangle conjecture and the converse for it. So I guess that's 4 properties that we learned today. And that's what you're going to be applying within your homework. So there's going to be some work with angles. And when you're thinking about the different angles, think back to these 4 properties. We also talked about some proofs today. We're going to continue to think through our logic in geometry as we go through this unit and come back to some of these proofs as well.